In this project we'll be making a custom vacuum nozzle, and these type of objects are quite cool to design and print. If you have some kind of tool that needs some kind of adapter for it or some kind of add-on, yeah, it's nice that you can just design and print and have it for yourself. Or maybe you can design it for someone else and sell it. So quite good opportunities. But this object is good to practice lofting. That's a new tool, and it combines like different types of profiles. For example, this round shape here and this top shape here, we will combine it and create this nice and sweeping surface. So enjoy, and let's start modeling. Alright, let's open up a new design. And the first thing that I need to do is create the base. That will be a sketch. Create sketch on the bottom plane. Let's pick a circle. And let's create a circle here. I will add a dimension, and this dimension will be the inner diameter of the nozzle adapter. So you must measure the tube that this will fit on. The dimension that I have is 31.8 millimeters. Enter. And now I will do another circle. And I will specify a dimension here between these two circles. It will be 3 millimeters. That will be the wall thickness of the adapter. Enter. Finish sketch. Now let's do the extrusion. Create, extrude, and pick both of these profiles here. I will extrude this 45 millimeters. This will be the length where the tube will fit inside. Click OK. And now what we need to do is create the tip. And to create the tip we need to create an offset plane. This will be a construction plane. So construct offset plane. Pick the bottom plane as a reference and drag the new plane up 120 millimeters. Click OK, and this plane is just like a construction plane. It's there temporarily for us to create a new sketch on. Now let's do a sketch, create sketch, and pick this plane here. And for the tip we will use a slot. So under create, slot, and pick this one, the center point slot. As it's a center point slot, the first point goes in the center. So click once, the second point goes to the side, and the third point goes here. Click escape. So this is a slot, and we can give it a dimension. I will give a dimension here that will be 13 millimeters, and this dimension here will be 21 millimeters. So I'll choose the size for it to be a little bit smaller than the base cylinder here. Finish sketch. And now we can do the loft tool. So under create, click loft. So this tool can join multiple profiles together in a smooth and continuous fashion. So here let's click profiles, and the first profile will be this top one, and click the plus sign and click the next one. So you can see that the loft tool combines two profiles together. There can be multiple profiles, but in this sample we're using only two. Alright, click OK. Let's take a look what we have here. If we compare it to this model here that's already done, we can see that this transition here is very smooth. So there is no sharp corner here. But on our version, we can see that this side is straight, and also here we have a sharp corner. And this one is sloped inwards. So let's take a look how we can achieve this form. let's edit the loft command now. So if I double click here, I can go back and change some parameters. So if I click here, profile 1, and change this dialog box from connected to direction, you can see it adds like a slope here, and it gives us this arrow that we can pull, and it shows how much we influence the shape, and it's called like a takeoff weight. So if you enter a number here, so for example 5, it's too much and it can't complete the shape. So you have to play around with the values here. I think this will be good enough for me. And also here, if I click profile 2 and change this from connected to tangent, so now it takes into account the bottom cylinder and adds a tangency to the connection. The bigger the tangency weight, the bigger the influence here. Let's keep it small. Let's say 0.3 will be enough. And the operation needs to be set to join, because we want to join these two bodies together. Click OK. That's looking good already. Now let's make the inside hollow. We can do that by using the shell tool. So modify, shell. And for the faces, let's pick the top one here and also the bottom one here. And the inside thickness will be a value of 3 millimeters. So our wall thickness will be 3 millimeters. Click OK. Let's compare this to the original model. Here we can see that the tip is cut at an angle. Let's make this now. Let's go create sketch and do the sketch on the front plane. I'll use the line tool here to draw a line. It doesn't need to be precise. Here I'm not doing any measurements, I'm just eyeballing where it should go. I will continue the line to create a closed profile. So line tool, make a closed profile. Finish. Now let's do the cut with extrusion tool. So create, extrude, select this profile and just cut away. And direction is set to symmetric, so it cuts in both ways. Click OK. Let's add a little fillet here. So modify fillet, select these two edges and just drag a little bit down. So it adds like a nice curved shape on top. Click OK. And let's add a little chamfer here. So modify, chamfer, select this edge, and the value will be 1 millimeter. Just a little bit to make it nicer. And also I will add a chamfer here in this edge, so this will make it easier for the adapter to fit on the tube. Click OK. The final thing that we need to do is add a little lip down here at the bottom. Let's create a sketch here. Let's do a circle. And let's add a dimension between this new circle and the base. It will be 1.2 millimeters. Just a little bit of offset. Let's extrude this now. So create, extrude, select the outer ring and drag the arrow up about 4 millimeters. And it doesn't matter that the distance says -4, it's just which way you do the extrusion. One way it will be plus, the other way it will be minus. So -4 is good. Operation set to join. Okay. And the final thing is add a little bit of fillet here. So this edge and this edge, 1 millimeter. Alright, we're done. So this is a quick and easy way how to create these type of adapters. For this part, the slicing is very simple and easy. The nozzle doesn't have any like negative angles, so no supports are needed. It can be printed without supports, and we have like a flat base here to position it nicely. The plastic is PLA, and I have chosen 0.20 millimeters in layer height. And for the wall loops, the standard is 2. When I slice it, I can see that it will try to make an infill here. It will be 15% dense, but in this case I want the part to be a little bit stronger, so I will just increase the wall loops to the let's say 6. And now with the increased wall loops we can see that the model is completely full with the wall loops, and this will make a really strong and durable part. And it will only take like 1 hour to print and 41 grams of material. So let's set it to print.